Alright, so yesterday we looked at two functions just on page 36. The first function was f of x, and if you guys could just remind me what is f of x? X squared
Minus 3.
X squared minus 3. Okay, and then g of x?
Square root x minus 1.
Okay, the square root of x minus 1. So those are our two functions. Then we went on to state the domain and range. And if we just look at the function of f to start, our domain, okay, that's a parabola. So parabolas, x squared minus 3, what would the domain be? All real numbers. Okay, I'm just gonna reintroduce interval notation. We could say that's negative infinity to infinity. Okay, or we could write it as x is an element of all real numbers. Okay, in set builder notation. And now let's talk about the range. Oops. The range for f. Okay, again we have a parabola x squared minus 3. What's going to be the minimum? Negative 3. Good. Okay, so is it going to include negative 3?
Yeah.
Yeah, so we're going to have a closed bracket, negative 3, and then it will go up to infinity. In set builder notation, we say y is greater than or equal to negative 3. And of that set, they're real numbers. Okay, so we have our domain and range for the function of f. Okay, now sorry, I'm just using a bit of space here. Let's just talk about the function of g. Okay, what would the domain be? The square root of x minus 1. Okay, we're looking at a radical function.
Greater than or equal to 1.
Yeah, because we can't take the square root of negative numbers, so we look at what would set this to 0, and it's 1. It can equal 1, so we're allowed to take the square root of 0. So our domain would be, in set builder notation, x is greater than or equal to 1. And in interval notation, we would have 1, and then it would go to infinity. But we wouldn't have an open bracket, right? Closed bracket, because it includes 1. Okay, now let's look at the range of g. Okay, we have the square root of x minus 1. What's the characteristics of a radical function? Okay, basically it's going to look like this. So where are we? It's minus 1, so it will look like that. What would your range be? Greater than or equal to 0. So in set builder, y is greater than or equal to 0. And in that set, they're real numbers. And in interval notation, it's going to equal 0, so we have zeros included in that set, and we're going to go to infinity. So we're going to need our domain and ranges of these for the second part, so that's why I just wanted to recap what they were. Okay, so for part D, in order to determine the domain and range of f of g of x and g of f of x, Aaron found expressions for f of g of x and g of f of x and used his graphing calculator to sketch the graphs of these composite functions. Okay, so on the left, he's graphed f of g of x, and on the right, he's graphed g of f of x. Okay, basically, if we read further down, says that there are some errors in Aaron's thinking. So let's just take a look at what he came up with. He said if we take f of g of x, that the domain is all real numbers, and that the range is all real numbers. Looking at this graph, do you think you agree? Yeah? Looks like it. Okay, we'll talk about this one in a second. Let's just start with f of g of x. And we'll see if Aaron was correct or not. Okay, so let's write out what the composite function actually is. F of g of x. Okay, g of x is being subbed into the function of f of x. And if we take a look at g of x, that was the square root of x minus 1. Was there a domain restriction on the square root of x minus 1?
Yeah.
Okay, let's take a look at g of x again. Okay, yeah, x had to be greater than or equal to 1. So when we're subbing that into f of x, that domain restriction, it doesn't just disappear, you have to still apply it. So we have to consider this when we're looking now at f of x. So let's just sub this into f of x, which was x squared minus 3. So now we get the square root of x minus 1 squared minus 3. And if we simplify that, the square root and the square, they cancel each other out. And we're left with x minus 1 minus 3. In other words, x minus 4. So if we look at the function x minus 4, we could probably all agree that the domain typically would be all real numbers for the domain. But we have to consider that there was actually a restriction in the domain earlier. X had to be greater than or equal to 1. So there's also a restriction in this domain. So if x has to be greater than or equal to 1, let's just draw an invisible line, even though you can see it. That's when x is equal to 1. We're just going to highlight on this graph where that exists. So given the domain restriction that x has to be greater than or equal to 1, the composite function, f of g of x, only exists here. Okay, now let's look at the restriction on the range from our f function. Okay, y was greater than or equal to 3. If we look where this is highlighted, where x equals 1, what's the restriction on our range as well? It's in line with negative 3, right? So our y has to be greater than or equal to negative 3. So to put this in a little better English, for the composite function, whatever the restriction on the domain is of the function that's going inside, so is being inputted, that's going to be useful when we look at the overall domain restriction on the composite function. When we look at the range, we have to look at the restriction that was on the f function. So the letter that's outside, or the first one in the composition, we look at the range of that. Okay, that's going to be useful for our end result. So the domain of this function is, of the composite function, is actually x is greater than or equal to 1, and the range is y is greater than or equal to negative 3. Before we go to the next one, I'm just going to fast forward to the next page here, and we're just going to read a few notes here. Maybe I'll put it to the middle of the board. Okay, so the first note is when we calculate an expression for a composite function, there may be restrictions on the domain and range, and we found that for f of x, and we also found that for g of x. There were restrictions. Okay, in most cases, the domain and range of the original functions, f of x and g of x, it will be different than the domain and range of the composite function. For example, the domain on f of x was all real numbers. What was the domain on the composite? Greater than or equal to 1. So those are different. The third point is the most important here. Okay, so I want you to just put a star beside that, or a box around it. Should try to do a better star thing. Okay, so the domain of the composite function, f of g, cannot be more than the domain of g. So, as we saw here, g of x was the square root of x minus 1. That had a restriction of x is greater than or equal to 1. So if that had a restriction, then the domain of the composite function can't be more than that. It can't be x is any real number because there was a restriction on g of x. Okay, the range of the composite function, f of g, cannot be more than the range of f. Okay, if we looked at x minus 4, you look at it and you think y would be an element of all real numbers, but because we had a restriction on, where is it, f of x, we have y is greater than or equal to negative 3. Okay, so if that had a restriction, then the composite will also likely have a restriction. So we're going to go back and try another one. If you wanted to, you could draw this function on the graph below, right here, or you could just highlight on Aaron's graph to show what actually applied. Okay, so you can highlight or you can just redraw it. So the first composition was f of g of x. Now we're going to look at g of f of x. Okay, Aaron's already drawn his graph, but let's actually solve for what that function would look like. Okay, so g of f of x. We're subbing the function of f of x into all the x's from the function g of x. Okay, f of x, just a reminder, was x squared minus 3. X squared minus 3 will replace all the x's from g of x, which was the square root of x minus 1. So we get the square root of x squared minus 3. That's replacing this x. And then don't forget to subtract the 1. So if we clean things up, we get x squared minus 4. Now, if you guys want, you can put this into your calculator under y equals, and you can graph it, and you may or may not see the same results as what Aaron got here. So when he graphed it, he has a little gap between the x-axis and the graph. Okay, there's a little bit of a hole there. Some of you on your graph, depending on how good it is, your calculator, it should actually go all the way to the x-axis. And it intersects the x-axis. So did anyone have a little gap on their graph? No? Okay. In some of the older versions, you get that. Okay, but Aaron had it, you guys don't, so you're lucky. Let's just take a look at this function, and let's talk about the potential domain of it. Okay, so if we take a look, it's the square root. Can we take the square root of negative numbers? No. So if we say put a 1 in there, 1 squared minus 4, it's like 1 minus 4, is that going to work? We get the square root of negative 3, so that's not going to work. Okay, what about 0? That's not going to work. Okay, what about if we put a 2 in there? 2 squared minus 4, 4 minus 4, the square root of 0? Yeah, we can do that. So that's possible. We know 2 is allowed. What about negative 2 squared? Still gives us 4. 4 minus 4 is 0, so that's allowed. What about negative 3? Negative 3 squared is 9, 9 minus 4 is 5. We can do that. Okay, what if we put negative 10? Okay, that's possible as well. Positive 10? Yeah. So what are the restrictions? What can we not include? Good, anything between negative 2 and 2. And by graphing it, you can visually see that, but sometimes it won't be exactly on 2 or negative 2. In this case, we're lucky. So for this function, our domain will be x is less than, I'll write it this way, x is less than or equal to negative 2, or x is greater than or equal to 2. And we're looking at real numbers. Now earlier I talked about restrictions in the domain from the inside function. Let's look at f of x. Was there any restrictions on that domain? But the composite function can't include more, or what's the word, how do I describe this? Basically, what did that last statement say? The domain of a composite function of f of g cannot be more than the domain. In this case, it will be of f of x. So this can't be more than that. Okay? X is any real number. That includes everything. But as we can see, there would be a restriction. So you have to look at your final composition to decide would there be a restriction. And we can't take the square root of negative numbers. So we have to imply that in our domain. Okay? For the range, we end up with a square root. We know that square roots will be above the x-axis. So we're looking here at the range from g of x. Okay, g is our outside letter, so we're going to look at our range for that. And here y is greater than or equal to 0. That's also going to be our range for the composite function. So for range, y is greater than or equal to 0. best thing you can do is just apply f of g of x or g of f of x and look at the function and then distinguish its domain and range. It's helpful to know the domain and range of the original functions as well, but if you're ever unsure, graph it, and you can just plug random numbers into that final function to test whether it would work or not. Okay, so that's lesson 5.